So now we're practicing how to use our TI calculators and work with graphing. And one of the first things that we want to learn, which is not listed on your notes, is how to turn your diagnostics on. And for this, we want to go down here to the catalog button. So I'm going to press second and then the 0. Everybody saw that? Second and 0. And that brought me to the catalog. And so you can scroll. It's really hard for me to scroll on this little emulator here, but you can scroll, or I think I can, let me see if it's, yeah. Okay, so you can also do it by alpha order, so I went to the D, and just as a quicker way. So now I'm going to scroll down here, and I'm going to go to diagnostics, and notice that it says off or on. I want to go to diagnostics on, and I'm going to hit enter, and it's asking me diagnostics on, and I'm going to say yes by hitting enter again. And so now that's done. And I will bring up what that just did as we get through it as we start working with the calculators. I'm going to show you why that was important here in a minute. But I just want to make sure that everybody can get their diagnostics on. So now what we're going to do is we're going to look at the notes that are given to us. It says plot the following on graph paper. We're not going to go through any of that plotting. What I'm interested in is making sure that everybody knows how to plug that into the calculator. So the first thing that I'm looking at is that it gives me my mass and my volume. Quick little reminder, mass and volume. Everybody remembers mass is on your Y, volume is on your X. So when you plug this in, we're going to see that we have some options for L1 and L2. So let's just go to the, and this tells you what to do down at the bottom. But I'm going to go to my stat button. This is where I'm going to try and get information into my list. I'm going to go to my stat button, and you should come up with something like this. So everybody found stat? And I want to edit my list, so I'm just going to hit enter. Oops. And I happen to have some stuff here that I want to get rid of. So just to show you what I can do, I can take that, using my cursor, my arrows, I'm going to take it up to my L2. I'm going to hit clear, and I'm going to come back down. I'm going to go over to my L1, go up to where it highlights the L1. I'm going to hit clear, and then I'm going to come down. So now that's just another option for you as to how you can start off with a clear list. So I want to be plugging things into my L1 and my L2. And we saw that mass is on the Y and volume is on the X. L1, what do you guys think? L1 should always be X or Y? X. And L2 should always be Y. This is really important. Make sure you write that down somewhere. L1 is X, L2 is Y. So now because of that, we know that our X is actually going, or L1 is actually going to be our volume. So make sure you carefully choose the correct column. I see that my volume starts off with 5.5 cubic centimeters. So I'm just going to, in L1, I'm going to plug in 5.5 and then enter. And that puts it in there. And I'm going to keep going. 1, 5.5, enter. And 2, 5.9, enter. Then I just scroll over to L2 and do the same thing. That's okay. Let me plug these in, and then I'm going to walk around and help you guys. Hold on just a second. I did not do that right. Oops. Okay, so 1.5, enter. 1.5.5. No. I know, I just can't choose the right one while typing up here. 42, enter, and 70, enter. Okay, so I'm going to pause this for a second and check on everyone. And now that we've all got that in our calculators correctly, now what we want to do is we want to take that information, this is from the aluminum, and we want to go ahead and calculate our linear regression. We want to get the equation for a line. So remember how we got to our list was we hit stat. We're going to do that again. We're going to hit stat. And notice up at the top that we have the ability to calculate. So I'm going to scroll over 1 and I hit calculate. And, oh, I scrolled over twice. That's the smartboard for you. Thank you. So I scroll over once to calculate. And what we want is linear regression. You can arrow down a few times, or you can just hit 4. Everybody see 4 is what we want? So I'm going to hit 4, and it's asking me, linear regression, is this what you want? So I'm going to hit enter, and that's going to pop up with some information. So everybody should get this. I'm going to go ahead and pause it again for a second. Okay, everybody's figured this out. So now what we're looking at is it gives us some information. It tells us our A and our B. Remember that our A is going to be our slope. So that instead of M, it's A, and that gives us our slope. You're going to get some goofy information. The data tables that are going to be provided to you are going to be kind of goofy. If you think about it, if you look at that one data table, what's your least number of sig figs? 1. You guys are good. There's one that says 70. So there's no decimal point behind that. So that's 1 sig fig. I really don't want you to report your slope in 1 sig fig. Let's just try and stick with a reasonable number. I might not grade it unless I really think that you're way off with your number of sig figs. So I would look at something like this and say, let's make that be about 3 sig figs. Just shoot for 3 sig figs. So your slope in this example is, or your density in this example would be 2.70 grams per cubic centimeter. You see what I did? I grabbed that number and I rounded it to 3 sig figs. So now I'm going to read through the questions there. We've answered a couple of these. What goes on the x-axis? We know that's volume. The y-axis is going to be mass. What is the density of aluminum as provided by the data above? That's what I just wrote in green. Why can't we just divide mass divided by volume for one of those ordered pairs? Well, we don't know. How many pairs do we have? I think there were 4 or something like that. Again, it might have been something like that to where that data, that best fit line, never even hit one of those data points. You need to use the best fit data, not just one of those random points, because that's not going to give us the answer. The other thing, notice that we've got, in theory, we'd really like this. We'd kind of expect it to hit 0 for our y-intercept, but it's a little bit higher than 0. You've got a question about this on your homework, the last one, number 10. I want you guys to think about why it wouldn't hit 0, what that would be. If you had something like this, what does that mean? What is this distance here? And I think you'll probably get that answer once you guys look at number 10. That might kind of lead you towards the correct answer there. So I'm not going to say much more about that. I'll let you guys kind of think about that. Last thing I want to mention on this is our R values. That's why we turned our diagnostics on. That's called a correlation coefficient. And what you want is your correlation coefficient, and it doesn't matter if you look at the R or the R squared. You want that correlation coefficient to be really, really, really close to 1.0. The closer it is to 1.0, the more precise your information, the more best fit that line is. If your data points are scattered all over the place, to try and make a best fit line is going to be a number quite a bit less than 1. So the closer it is to 1, that just tells you the better your data fits that best fit line. Okay, so we have one more that we're going to do. Let me see if I can clear some stuff out here. Hold on. And we are going to do this other problem as soon as I get myself ready. Okay, so the next problem says that we've got, we're looking at lead, and we've got more data. We've got 3 points that are given to us, and we just need to plug those in. So maybe one of the easiest things to do is just go to Stat. You're going to edit, so I'm going to hit Enter. And remember, you can just go up, above, clear, down. Go over to 1, up, above, clear, and then down. So now you've got clear lists. So I'm going to pause this while everybody plugs in. Okay, so everybody... Okay, so we've got all of this information is plugged in. Again, if you were asked, let's see what our questions are. Our question says, what is the density of lead as provided by the data above? For this, you would have to say 11.9 grams per cubic centimeter. And then we have the question, hey, will this substance float or sink in water? Well, you guys know what lead's going to do, but let's say it was a mysterious substance that we had no idea what it was. if we are looking at this, let's say this is the density of water right here. We have blue and we have red. Which one of those is going to float in water? The red. The red would be less dense than water. The blue would sink because it's more dense. What is the density of water? 1 gram per cubic centimeter. Everybody should know that. As human beings on this earth, you should know what that density is. I think that's about it. So, good job. Thanks.